Let's get into Kmeans. I think this will be the most interesting thing we'll work on this week, but also it's going to be kind of daunting. So just bear with me as we go through each step one by one. And for this, I also recommend going through it step one by one, just to sort of build up and get comfortable with the process. So again, we don't need a GPU for this notebook, so we can just go ahead and run this, and we'll see again that NVIDIA SMI command not found. Then what we'll want to do is we'll want to connect to Google Drive. And we'll go ahead and run this. All right, and while that boots up, let's talk a little bit about what we're going to do. So one of the things we're going to need to do for this material is actually convert our clips into frames. And we'll see why that is when we get down into comparing the two side by side. But essentially, we need to run over our clip paths, all of our clips, and convert those to individual frames. And the way that we should probably do that is, let's go back to our folder structure here. If you haven't been able to figure this out by now, it's probably best to follow the order that I have here. It might reduce issues. Obviously, it's like everyone has their own sort of file structure preferences, but I'd say for now start with this, and then if we run into issues or if you want to do a different thing, we can talk about that later. So what I'd say is go into AlgoFilm and make a new folder and call that folder frames. I think we did that before in the FFmpeg session, but just to be safe, if it's not there, go ahead and make it then. Next, what we're going to need to do is we're going to need to point our folder to a clip path. And this clip path doesn't need to be this master path. In fact, it probably shouldn't be. What I would recommend you do is instead go into your individual clips here and grab one of them. So I uploaded one of the Blade Runner trailers, and I'll copy this path, and then I'll go ahead and paste it in. The other thing we're going to do, I'm going to quickly clean up some of my files here real quick, so give me 1 second, let's just copy this. That should delete that folder just so we can rebuild it. There we go. And if I refresh this, that folder should disappear. Yep, there it goes. So what I recommend you do is in your frames folder, make another folder and name it the exact same as your clips folder. This is kind of we want to start to establish a bit of a process here in order to, make sure that things are consistent. So let's just call this Blade Runner trailer. And we'll copy this path and we'll paste this into the output. And what this is going to then do while we run this is it's going to take every clip inside of this folder and convert it into a folder of frames inside of this folder. So let's go ahead and get started. I might stop this before we actually get all the way through it because, to be honest, I don't need to do this again because there's a lot. It takes a little bit of time. I want to say this will take about 10 minutes to actually process. And I should say this is a 2.5-minute trailer. So you can imagine that doing this for a feature-length film would be kind of a lot. And we don't actually need to do that for this. We'll go through a couple steps inside of this notebook, and you can kind of decide what's worth it for me to do before digging into all the process here. So while this runs, we can go ahead and open up this folder, and we'll see it's now creating a bunch of folders in here. And those folder names are the exact same as the clip name here. And inside of here, then, we are going to get every single frame produced. Okay, I'm actually just going to stop this. You can let it run the entire time you need to over one of your folders just so you have access to everything. I'm going to stop this just to be safe though, just because I'd be here for a while recording this tutorial if not. And actually might not let me because I'm in a weird for loop. Let's see. Okay, it might force me to create all these. Messing with FFmpeg and a for loop in a coding cell seems to sometimes break the stop command. That's right. So while this processes, let's go and walk through what we're going to do in the next couple steps of the notebook. So next thing we're going to need to do is I'll actually queue this up. I don't know if I've mentioned this before, but you can queue commands in Colab by just hitting the play button. So you'll see this one's still spinning, which means it's still processing. We can queue this guy up by just hitting play, and what it'll do is it'll wait until this cell is finished. This cell just includes a bunch of functions. So you'll actually have seen these, right? Like get duration, get dims. I don't think we're actually going to use those in here, but I added them because I was previously using them. This saves an important thing called RGB to hex, which we don't really need to care about, but to produce video in FFmpeg, you need to convert solid colors to hex codes. It's kind of annoying, but that's how it works. So this is just a bunch of functions that we're going to use later down. Okay, next. So remember how I mentioned that we are going to process our like image stills in lab colors, and that actually ends up being slightly better. I just want to go through what it looks like in RGB versus what it looks like in lab, and then you can decide like, hey, maybe I actually like RGB. I think lab is still going to be slightly better on average for most people, but we'll see. So the way that this is going to work is we are going to pass in an individual frame. So we're going to pass in one frame, do the Kmeans over that single frame, and then look at the output from that. So we need a frame. So we're going to go back into these frames here, and we're going to pick one of our folders, and then we're going to look at one of the images in it. So I'm just going to go into this one, and I want to pick a frame that has some color in it. This is kind of good. I mean, this will be interesting because it should be black, blue, and teal. That's sort of the ideal color range we're going to see here. So let's go ahead and use that image. So we'll copy that frame. So for this one, we're going to pass in a single frame. And then, actually, you know what? I want something with a little more color. I do think for RGB, we should see if there's something with a little bit more like photographic color. Let's see what's here. That might be good. Let's try... Yeah, let's just try this. Did I just do that? I did just do that. Let me just reopen that. I meant to close that tab, and of course I hit. Okay, I think we're fine. Nice thing about Colab is it does stay running in the background if you're on the Pro Plus plan. So this paid off for me. It worked okay. So again, we're back into our folder here. I've now pasted in the path to the actual image. So again, this points to a JPEG or a PNG, some kind of image. You could even upload a different image if you wanted to, that isn't a frame from your film if you want to play with it. And then we need to define how many color clusters we want. So, you know, I would say anything between like 5 and 15 is generally good. But the nice thing about this is we can play with this. So we can play with these values, and it's not the slowest thing on earth to play with a single image. So we'll go ahead and hit play. And here you go. Here's my color palette from that. Let me just open that up again. Ooh, if I can find it. Let's see. What was the folder path here? Scene 14, 6. Okay, so I'll go film, frames, Blade Runner trailer. This is scene 6, scene 14. Scene 14 and frame 6. So if we scroll down here and look, maybe this is pretty good. I mean, it definitely seems about right. Even the black is kind of brownish, which is interesting. Don't necessarily pick up some of the reddish, the bright red yellows here. Maybe that's not really a part of the cluster. So let's go ahead and run this in lab and see if we get different results. So all I'm going to do here is I'm going to copy the exact same file path from up here and paste this down into this one. And this one uses lab conversion. So we're going to convert our image to lab, do the Kmeans process in lab, and then convert it back to RGB to look at the color palette. So we can go ahead and run this. And I kind of like this palette a little bit more. Actually, the brown looks darker. There seems to be a wider contrast between these colors, and I actually think the red here is a little bit nicer. Well, give or take. What I think is interesting here is actually the reds and the mauves are swapped, but they're pretty even to begin with. So again, on a single color, you might find that like you like the RGB palette a little bit more, you like the lab palette a little bit more. Remember, these are non-deterministic, so they'll get different results. So if I were literally to rerun this, I should get a different result. It'll be very slight, and I probably won't even be able to notice it. Yeah, can barely even notice it, but it probably is different if I were to actually like download the images and compare them side to side. So this is just on a single image. Now, what if we want to take every single frame from within our film and run that over every single, oh, sorry, actually, there's one more step here. So this next cell is actually doing the exact same thing. All it does is actually output a larger file. So if we run this again, so we'll paste this in here, the path in, and then we'll set the output just to be here so we can download it, and then we'll save this out. So this will save out a larger image for us if we want it. And here it is. So the way this works is it'll grab the dimensions from my actual file, from my image file, and place it to be about the same amount. So if you want to look at everything bigger, a little bit more up close, you can see that. One other note about this tool is often at the very edge, there'll be a little bit of color pixel left from the first color. That's just an issue with averaging, or just like basically rounding up, essentially. So it is an imperfect design tool. If someone wants to fix that for me, you're more than welcome to. If not, we can always go in and crop our video a little bit, and it's totally fine. This is more about visual analysis than final outputs, as most of this class is. So go ahead and take a look at that. And then, so now we want to run this on an entire folder of films. So the thing about this is, well, first off, this is very, very slow. I actually don't necessarily recommend this unless you're really interested in the look it creates. So what this will do is we'll actually generate a frame for every one of these frames inside of our video. This is going to produce a lot of files. I've already done it, so we can actually see how many files it's ended up producing for a 2-minute long piece. So algo film, frames, Blade Runner trailer all. And if we just come in here and we copy path and we say, oh man, I never remember this code. What is it? WS pipe -LC. Let's see if this works. Nope, not right. Okay. Nope, not right. Okay, let me just find out what this is. Linux count files in directory. Yep. I had the parts right, but definitely messed up the order. Okay, let's do this. So it is ls dash, and then we'll paste in our path here. So for a 2.5-minute film or trailer, there are 3,552 files. Now, running Kmeans over all of that over and over and over again, I think it took me about an hour previously. So this is not the easiest thing to do, or not the simplest process. If you want to do it, I do recommend it. I will post an example of what this looks like run over Blade Runner. Let me see if it's actually here. Let's see, output. I think it might be this. Let's download and see. Remember that Kmeans is non-deterministic, which means every frame it's going to be slightly different because of some random generalization, which means it's going to be kind of flickery. I believe this is the right thing. Let's open it and see. So this is what it looks like. So you can see it does do a decent job of pulling in the colors, but one of the challenges is that it is flickery. It's not very stable. And that's just because of that randomization process that's a part of Kmeans. Now, again, this took an hour to generate. The code is all here to even do the stacking stuff. I'll walk you through that in just a minute. So maybe it's interesting. Maybe it's worth playing with a trailer just to sort of see how the colors look. I do kind of like that, especially in this trailer. There's lots of stuff fading in and out, and you can kind of see fading happening in the actual color palette because, as it fades out, there's more black, there's other things in here. So it is kind of interesting to actually visualize it this way. It produces a lot of files, and it produces a fair amount of time to actually generate this. This took an hour to generate. Maybe that's good, maybe that's not. But that's sort of this process. So the steps for this are, you'll need to, using FFmpeg, convert all of your files to frames. Now, we previously did that for clips, And there's a good reason we did that for clips, and I'll show you that in just a minute. But we also probably realistically just want to do it for the entire file. So that's why I made a second folder that was called, what was it called? BR Blade Runner Trailer All. So this includes all of the files broke out into individual clips. This one is just literally all of the images. And you can see the code that's written for this here. Again, I would refer to your the FFmpeg session we just did earlier this week. And you can look at that to understand exactly the inputs and outputs. And if you want to change anything, you can. We'll delete this because, well, you know what? I'll leave this in. I think it's probably good to be able to see how many files are produced here. So what you'll do is you'll just take this folder path and paste this in. And then when you run it, it will tell you how many files are inside that folder. Move this up a cell. Okay, so now what we need to do is we actually need to run that Kmeans process on every individual frame. And the way to do that is we will take this path and we will paste this into the frames variable here, and then we'll create an output path. So for the output path, let's go ahead and make a new folder here in outputs and call it Blade Runner All Frames Kmeans. Now obviously name your file whatever you want to name it. Paste that in, and then you can play with the clusters again. We didn't even really play with clusters here, but you can change the number of clusters here. So let's say we want to look at this as 15. Sorry, I know I'm bouncing around a little bit, but we could play with this and produce more colors. That's what that one image we were looking at before looks like when we split it into multiple colors. We could also go down to 3. So that's what it looks like with 3 colors. So you can play with this. I mean, I think you do 2 and 1 even, but I tend to like it between like 5 and 6, not 56. That would be too many. I tend to like something around that range because it gives a good idea of what the palette looks like. So anyway, sorry, that is what you can set for end clusters here. Now, again, you're going to hit play and run this, and it will take it about an hour for a 2.5-minute film. So just beware of the time it's going to take to run this. You know, maybe set this up in the morning, do your morning meetings, or, you know, go for a walk and then come back and it should be ready for you. The last thing we need to do, because remember that's going to produce just a series of frames, we need to run that FFmpeg command in order to produce the actual output video. So again, refer to the FFmpeg session we just had, but essentially you feed it in your folder. So we would feed in this folder, and remember to keep the %09D that sort of gives us the frame count. You'll want to paste in the exact same frame rate that you previously had. So if you don't know what that film's frame rate was, this command will run that to let you see what it is. So if you run this on the individual video, remember that it'll output somewhere in here the frames per second. So 23.98 is what Blade Runner was under. You'll also need to give it the output where you want to save it to, so you can do that as well. And lastly, I want to show you how you do that stacking video thing. So when I stack these videos on top of each other, let me just pull this up again. So in order to stack these videos, all I do is take the video I just made, which is the color bars, and take my input video and stack them on top of each other. And FFmpeg has a pretty simple way to do that. But all you need to do here is add in your original video path. The path to your Kmeans colors goes here, and then your output folder goes here. So as long as you have all those 3, you can generate a stacked video. And it's kind of nice to just, like, share that with people, because then they can sort of see what the input video is and how the output was color extracted. So it's kind of cool. All right, so that's everything working for an individual frame. Now, what I highly recommend you do is play around with this section, just operating on a single frame before you jump and do anything else. So find out, like, oh, do I like 10 clusters? Do I like 12? Let me play with a couple different images, see if I'm getting the right results that I would expect, that sort of thing. Once you've sort of come to a point in a view where you're like, oh, okay, these are the cluster numbers I like, then you can jump down to where we're going to do video processing. So unlike a single frame, we can also operate on video. And the way to operate on video is the reason we made all these clips over here. Where did I make them? Here. Is because what we're actually going to do, you can imagine like in a clip, maybe the lighting changes, or maybe you're in front of a car siren and you see blue and yellow, or sorry, blue and red, blue and red, blue and red in the little like siren thing. We want to be able to capture the colors over a clip, not just individually in a single frame, because if we look at just a single frame, that's only going to give us the color palette for that frame. And again, over a clip, we might actually have some color changes. So it'd be good to be able to capture the predominance of those color changes as well. So what we're going to do in this section is we're actually going to point at a video. So we'll actually look at a video. So we can grab, actually let's do this. Let's grab, what it was scene 14. So let's grab scene 14, which was the one we were playing with before. And then what we're going to do is we're going to output this. Let's just output this to content so we can look at it. And what this is going to do then is it's actually going to take a handful of frames from our video, stitch them together, and then operate Kmeans over the entire video. So you can sort of imagine pulling down a couple frames, opening them in Photoshop, and stacking them side by side, and then you run Kmeans over that. And that actually ends up being a way to track predominant colors over an entire clip. All right, with that, let's go ahead and run this. So we're going to run the cell. And there it goes. And if we look down here in our console, we'll see here are the colors that it spit out. Now, is that right? Is that really scene 14? Interesting. Maybe we should check out what scene 14's clip actually looks like. Because I thought that was going to be red, but maybe there's color changes. Let's see. I'll go film. Clips. Blade Runner trailer. Scene 14. So let's go ahead and download that. And while we're at it, we'll see at the very end in here, if I refresh this, that here is our trailer. Or here is our color extracted from that clip. Let's go ahead and open both of these. So here we go.
I've got 4 skin jobs walking the streets.
So it looks like because of those fades, it offsets some of the colors. You'll notice this doesn't change because it's just based on that clip. But because this clip actually doesn't contain just those flashing lights, right? We were looking at just the frame from here. But in reality, there's a bunch of these fades that are including lots of cool colors. So that's why our frame is coming out like that. Now, this is sort of the downside upside. Like, this is the thing we have to balance out when we do this process. But overall, I could say like this is probably an accurate selection for all of the clips that are or all the frames that are included in this clip. So there we go. That's how it works. Again, it's kind of hit or miss. Once we've dialed this in a little bit more, maybe we do want to go and check out what it looks like if we do 10 colors. Maybe if we do 10 colors, we'll get that red in. Let's see. I think I have to delete this. Let's see. Delete. And let's just run this again with a cluster of 10. You'll see it gets a little bit of maroon in here. So again, we would crank this up to 25. It's because it keeps seeing this file here. There's a little catch in here to make sure that I'm not I'm not doing the same file multiple times. But in this case, I actually do want to do that. So just make sure you delete that video file. And there you go. If I make it 25, I see little slivers of red in here. So again, ideally, like you get all the colors, but realistically, there were only a couple frames of red in that entire clip. So you have to kind of stretch this all the way out to a lot of clusters in order to get that color. Now let's take a look at what we're actually going to do, which is like this will be the sort of the final piece of this Kmeans process. So we're going to do that same video section, but instead we're going to do it on every single clip of our file. So this time, instead of running it on that individual clip of 14, we're actually going to run it on this folder, so on the trailer folder. So we'll copy this path, and we'll paste that into the clips path. And you'll see this time we have our JSON path up here. So again, this will write to our JSON. So what we're going to do is we're going to process all these videos. And while we do the Kmeans, we're also going to save that Kmeans and the weights of each color to our JSON file. So that way we can use them again later. Again, remember, Point of this JSON file is we save all of our data there and store it there, so we don't need to constantly rerun this process because this isn't the fastest process. It is quite slow. So just keep that in mind. So we'll paste in the clips path, and we'll want to figure out where to save these. So let's save these in a new location. Let's go to output, and let's go, I've got so many folders in here because you've seen I've been testing. So let's do a new folder, and let's call it Blade Runner Clips Kmeans. So we'll copy that path, and we'll paste it in the output, and then here again are your number of clusters. Now this process is actually much, much faster than running it on each individual frame, because remember, each individual frame requires its own Kmeans process. This, we're actually just going to run a Kmeans per clip, and it will be much faster. It'll take like 10 minutes instead of an hour. That's kind of the benefit of doing this because we're actually combining a bunch of data together. So in this case, actually operating on the clips is faster. I sort of mentioned in our slides that maybe that isn't always true, but in this case it actually is because we're really only operating on a handful of frames per clip, which is a nice benefit of that. I'm not going to run this because it does take a while, but you can run it yourself, and you should, at the end, get out a series of clips. And those clips will look like, let's see, which one is it here? I think it's this one. Yeah, so each one of these is its own video clip, where the video clip itself is static, meaning there is no color change in that clip, but the length is actually matched to the input duration. So what you can do then is once you have that, then you can resequence everything back together. So this cell will actually run all of those and put them back together using this output path. So you do need to run this in order to see it. So you'll run it, it'll save out each video. Then you'll come back down here and you'll run this one, and this will give you all the pieces. Then you'll run this cell, and that will paste them all together into a single file path, or into a single file. Then you can actually stitch those files together. So again, you can stack them. Unfortunately, for whatever reason, you can't stack them using FFmpeg. I think because of there's something weird in the codecs between the two. But you could stack them in the way that you do, like, I don't know, in a video editing program or something. This is here if you want to try it, but it didn't work for me, and I don't know why. I do have an example of what that looks like somewhere. I'll link to it in our syllabus. Sorry, this is clearly the last video I'm recording for the week, and my brain is shot at this point. But this will allow you to process all this data, and the most important part is that we're saving all of our color data into our JSON file, so we can use it at a later date. One note about this is this does require you to run it on each clip. So you need to run it on each clip, and then that data will be saved. Unlike the other batch processes where we just sort of run it over the entire JSON file, I'm choosing to have this operate on individual clips. You'll need to run this one by one on each of your folders and your clips. If there's enough complaints, I might change that, but I think this is actually a little bit safer in order for us to sort of like process our data and make sure we're not doing too much and not spending lots of hours just doing the Kmeans process. So a couple other notes. One is this does create a lot of frames in your files. Again, depending on how much drive space you have, you might want to, at some point when you're finished with this process, clean up all these frames. There are a lot of frames in here, and this is quite expensive in terms of hard drive space. So if you have a small drive account, you might want to delete these. I would say the easiest way to do this is actually to go to your drive account and go over here. I'm going to log in my NYU account just so you can see it. And then go to your Algo film folder. And then inside of frames, I would just delete each one of these folders. You could just do this and hit move to trash and then delete it. I don't know how much space that actually takes up, but it's probably a lot. Because PNGs of a certain resolution are, maybe a megabyte a piece or something. And that can add up quite quickly when you're doing this on full films. So just be aware of that. I'm actually gonna, I'll leave them in the trash. It's fine. I can remake them. It's honestly easier to remake your frames than it is to like store a bunch of data and be like at your limit for your drive account. So keep that in mind. Another thing I want to mention is I've done a lot of testing with these files and it should work correctly, but there is always a chance that your JSON file can be corrupted. Now, don't freak out because we can actually restore it. But if you do get an error where you start to see an error with your JSON file, before you worry or get concerned, just DM me over Slack and we can make sure that you have not completely lost all your work. One of the downsides of this process is because it can take days to operate on all of our video files. This JSON file is pretty important to us because we don't want to lose any of our data and have to redo a bunch of stuff. The good news is that because we're saving it in Drive, that file is actually backed up. So there's actually versions to this file. So if we go here and go to file information, you'll see there's versions. So if we do happen to screw up something, and I hope my code doesn't do that, but if we do happen to have that happen, we can always back it up to a previous version and maybe lose a couple hours of work rather than a couple days of work. So just keep that in mind. I want to make sure that people know about that before they go like, oh no, I screwed this up. Let me delete this file and restart over. We can always go back to the versions and pull that out. So just be aware of that and don't worry too much, because I don't want anyone feeling like they lost days of work because I'm a bad programmer, which I am. But I want to make sure that we can save that work. Lastly, I was planning on covering sorting by hue, saturation, and value. But honestly, I think we have enough work to do this week. So I'm actually going to pick this up next week. So I'll do a little lecture on how to do this, the right sort of processes. Then I'll record a tutorial, and then we'll have a whole bunch of other stuff next week as well. So don't worry, we're not going to cover this week. I think this will be cool enough for us to do, and then we'll come back and start to play with actually sorting our videos by certain values. Okay, we have one more tutorial left, which is working on shot types. So I'll see you over there.